Project in Form 42, the critical path method. Presented by Mark Hunsay, Mark Vincent Santos, Cruz Kenneth, Piapi Junel, Marino Janlari, Michael Robic Lagrimas, Michael Bilbao, and Sandy Santa Rosa. Definition: critical path is a sequence of activity between a project start and finish that takes the longest time to complete. Critical path method is based on mathematical calculation and it used for scheduling project activities. In 1950, critical path method was developed by Kelly and Walker to assess the building and maintain of chemical plants. The initial critical path method was used for managing plant maintenance project. Parallel activity: there are two activities which begin at the same event and at the same event. These activities are called parallel activity. Path: a path is a series of adjacent activities leading from one event to another. Critical path: a critical path is the sequence of critical activities that form a continuous path between the start of project and its completions. Forward pass: the early start and early finish time calculated by moving forward through the network. Consider maximum. Backward pass: the latest start and latest finish time calculated by moving backward through the network. Consider minimum. So it is basically the longest string of activities. The longest string that is a critical path. Now, if we add duration of all the activities, on all the path in your network diagram, the one with the highest, the critical path, with the highest duration. The highest duration is the critical path. You need to understand that you need to add the duration. You need to understand that you need to add the duration. The highest duration is the critical path.
Let's start. A has no predecessor. B and C need A to complete before they can start. D and E need B to complete. F needs C to finish. G needs D and E before it can start. H needs E and F before it can start. And I need G and H to be completed and finished.
Here is the data showing the activities and estimated time. A has no predecessor, so it will be 0 and add it to the time. So the answer is 4. B needs A, so we'll add 4 and 9 equal 13. C also need A, so we will add 4 and 12 equal 16. D and E need B, so we'll add 13 to both of them. So 13 plus 6 is 19 and 13 plus 2 is 15. F needs C, so we add 16 and 8 equal 24. G has two predecessors, E and D, so we'll choose the higher time, so it is 19 and we add it to 3 equals 22. Same with H, which has two predecessors, and E and F choose the higher time, which is 24. Then add it to 2 equal 26. Also same with I. We will choose 26 and add it to 6 equal to 32. And the same time is 32. Now, 32 is the finish time, so we'll put 32 in I and minus it with 6 equal to 26. We will put 26 both G with 3 minus 26 equals 23. And H with 2 minus 26 equal 24. G has two predecessors. So we will put 23 on D and E. And 6 minus 23 equals 17. And 2 minus 23 equal 21. H also has two predecessors, E and F. So we will put 24 on F and minus it to 8 equals 16. E doesn't need H because we will choose the lower time. F needs C, so we'll put 16 and minus 12 equals 4. B has two predecessors, D and E. We will choose the lowest amount of time, which is 17. We will minus it with 9 equals 8. Same with A. We'll choose the lowest of time, which is 4, and minus it with 4 equal to 0. The slack of A is 0. The slack of B is 4. The slack of C is 0. The slack of D is 4. The slack of E is 8. The slack of F is 0. The slack of G is 4. The slack of H is 0. And slack of I is also 0. And the critical path are A, C, F, H, and I.